Okay, we're going to look at graphing linear inequalities. So they're lines with inequalities, and they have two variables, just like a regular linear equation. There's one difference when you're graphing them, is that you need to pay attention to two things: whether the line is going to be dotted or dashed, or whether the line is going to be solid. Okay, if it's solid, is when it's greater than or equal to, or less than or equal to, and when it's dashed is when it's just greater than or just less than. The dashed is kind of like the open circle on a number line. It's not shaded in, where the solid line is like the shaded in circle on the number line before you shade one way or the other. So here are the steps. Graph the boundary line, okay, just like you would. So you first have to put it in slope-intercept form. Before you draw the line, make sure you decide, is it dashed or solid, and draw the line. Then you're going to pick a point to see if that side of the line, that half plane, is shaded or not. If the point becomes a true statement, then that half of the plane is shaded. If it's not a true statement, then the other side is shaded. Alright, let me get to an example. Okay, so this one is already in slope-intercept form. Remember, if it's not, and if you multiply or divide by a negative, you do still need to use that rule of changing the inequality. But here I have a slope of positive 3, a y-intercept of negative 2. I'm going to graph my y-intercept first. Sorry, it's negative 2. Okay, and from that point, I'm going to use my slope, rise 3, 1, 2, 3, and run to the right 1. I'm going to go in the opposite direction, 1, 2, 3, and go the other way. Notice that before I draw my line, I'm checking two things. Is it the correct slope? Okay, my slope is positive here. I have a positive slope of positive 3 here. So they match as positive and negative. The next thing I need to pay attention to, is it going to be dashed or solid? Because it's not equal to, and it's just greater than, I'm going to do a dashed line. And now to pick a point, I need to tell whether this side is going to be shaded or whether this side of the graph is going to be shaded. And what you're really supposed to do is pick a point on the graph that's not on the line. That's important, that's not on the line. So I'm going to pick the point 0, 0. That's always an easy one. If I plug it in, 0 is greater than 3 times 0 minus 2. 0 is greater than 3 times 0 is 0, minus 2 is negative 2. So if this is a true statement, then I shade the half that the point 0, 0 is on. If it's not a true statement, then I would shade the other half. 0 is greater than negative 2 because it's a negative number. So that means I'm going to shade this part of the graph that point 0, 0 is on. A shortcut here that I'll teach you, but understand that this is what this means. What it means is if I pick any of these points that are in this shaded area, if I pick any of those points and plug them back into this inequality, it will come out to a true statement. If I pick any of these points that are in the half plane that's not shaded it will not be a true statement. So these are all the solutions to that inequality. All of these are not solutions to that inequality. Okay? An easy way to remember is once you get it in slope-intercept form, it has to be in slope-intercept form for this to work. If it's greater than, you shade up. If it's less than, you shade down. Okay, the map here shows the number of tickets needed for a small ride and the number of tickets for large rides at the fair. You do not want to spend more than $15 on the tickets. How many small or large rides can you ride? Well, first decide how many tickets are you going to have. And it says right here that the tickets are going to be 25 cents a piece. So to tell how many tickets you're going to be able to get, $15 divided by the 25 cents per ticket is going to be 60. Okay, so you get 60 tickets. This is one where you're going to have two variables here. You're going to have an X and a Y. Still label them. For my X, I'm going to have X as the number of tickets for the small rides. I'm sorry, X is just going to be the number of small rides that I'm going to ride. Y is going to be the number of large rides that I'm going to ride, because then I'm going to have to multiply those by the number of tickets it takes to ride each of those. So I have 3 times X, so for every small ride I ride, I have to use 3 tickets, plus 5 times every large ride. Now it says I don't want to spend more than $15. I only have 60 tickets total. So that means that all of this has to be less than or equal to 60. And from here you can put it in slope-intercept form. Subtract 3x. 5y is less than or equal to negative 3x plus 60. Divide by 5. Now, I'm not dividing by a negative, so I don't change my inequality. Less than or equal to negative 3 over 5x plus 12. Okay, so here are some you try problems. And here's a joke for you. Would the 0 say to the 8, "Hey man, nice belt."